Good morning, everyone. Welcome to our webinar today. We will be exploring how we analyze 3D scan data with BuildIT construction. BuildIT allows us to monitor projects in real time, compare 3D scans to design, and basically helps us save time and money. So before we get started, I'd like to give our presenters a chance to introduce themselves. They can share a little bit about their expertise and how it connects to today's topic. Let's start with Irene.
Hi, I'm Irene Radcliffe. I've been with Faro for 8 years now. Been most of my career in the oil and gas industry, so doing construction in that field as well. So really understanding the benefits of being able to, see issues before they start, which we can certainly do now with the scanner. I'm Senior Business Development Manager, and I'm also the Product Manager for BuildIT Construction. Pass it over to Noah.
Hi, I'm Noah Wells. I've been with Faro for about 3 years now. I'm currently the primary trainer for BuildIT. I work a lot with customers on dealing with problems and working on how to make the software meet their needs exactly, and kind of optimizing and tailoring the software for them. So yeah, that's me.
And my name is Melinda Hannison. I'm going to be a presenter today as well. I deal with technical sales, and I'm a 3D specialist for DiCarlo Precision. We're based in Maryland in the US. All right, we're moving on to giving you a little highlights on scanning. So if you've not seen before, but Faro's just come up with the new Focus Premium models. We've got 3 new models, the 100-meter range, the 200-meter range, and the 400-meter range. This is the core Focus Premium, the Premium, which is now the 200-meter range, and the Max. They all have the same accuracy. The 3D accuracy for them is 2 millimeters. And the speed is about 2 million points per second. So it's a great scanner, specifically used for BuildIT construction. But with BuildIT construction software, you can use any scanners out there as well. But our scanner it's fast. We have what we call the Flash. It's the hybrid reality capture where you can capture scans in 28 seconds. The Focus itself weighs about 10 pounds of the dimensions I showed. It's one of the best scanners out there in the market that will give you very good data. The workflow, if you use the Faro scanners, we have what we call the Stream app. We use the SD card to basically transfer the data. We do register our scans in Scene. And from there, we extract and evaluate our data using as-built and BuildIT construction. As-built will actually allow you to model your data and extract your information for as-built drawings. And BuildIT construction is what we're talking to you today about analyzing your scans. And from there, you can basically deliver it. We do have a Sphere XG platform where you can actually have a look as a visual 3D digital twin, which allows you to collaborate and share your information as well. Let's move on to what we'll hear for today, the Faro BuildIT construction. And I'm going to leave it to Irene to actually explain what BuildIT construction is all about.
Construction is a really good tool for visualization. So in a lot of cases when we look at our scan data, you're out there and you're in the construction site. You're looking, for example, like a concrete floor slab or beam installation, where you look at the scan data and it looks pretty flat. Beam looks pretty straight too. But there's the nuances in this are really hard to they're there and they're critical to the construction process, but how do you see it? So what BuildIT does is allows you to take that visual information, so something that we can't see with the naked eye, and just quantify it. Show me just exactly how flat that floor is. Show me how much it's off. Show me where the highs and the lows are. So in a nutshell, what BuildIT does is it measures something to something. So it could be using a point cloud to a point cloud, so you can see what's changed over time. So using just kind of looking at what we've got here, right? Validation to design specs. Let's bring a CAD model in. Here's what this building's supposed to look like. Here's what this parking garage is supposed to look like. And let's scan it. Let's overlay them and see if that is actually what it looks like. And if it's not exact, how much is it off by? Right? Critical to the next step of construction. Tolerance evaluation. This tends to be a big one that's come up lately just because of the amount of fulfillment centers and, robotics, you do order picking and large warehouses. So, your floor looks really flat. How flat is it? There's a tolerance there, right? So we can actually quantify that and measure that through BuildIT, through either, using just plain fitting or using, like I said, back to the CAD model again. And positioning. So, let's say we've got these beams installed, and you've got is it more than an inch out of place? Is it, let's compare where it should be to where it is. And again, that's something that's really difficult to see. But by colorizing the point cloud or alternately colorizing the CAD model, we can really see what that looks like in terms of the comparison of where it should be to where it is. So,
all right. So next question for you, probably, Irene, is why use BuildIT Construction?
Well, I mean, anybody that's ever worked in the field in construction, when you're out there and somebody's installed a pile, and you need to put a beam on that, or you need to put a column on that, and it's in the wrong place, that's a big problem. And as soon as you find that out in the field, your cost to fix that is just exponential. So, it pushes your schedule back, cost to get people to come in and fix it, all of that. You can see in this curve here, this time and cost go up. If you see that before you get to that point, right, you can adjust that and you can fix it. So again, it's that difference of understanding the risk earlier saves you a lot of time and a lot of headaches as the project continues. So it's taking that risk and we're eliminating that risk. We're understanding what that is. And being able to mitigate that at the beginning of the project when it's cheap, as opposed to the end of the project when it's super expensive.
Yeah, that reminds me of one of the customers I was working with recently, where we had to scan your concrete floor panels. They had a modular building, and so they basically created floors for the hospitals, and they make modules of the hospital floors for the bathrooms. And they needed to find out the slopes. They needed to find out the service deviation against CAD. So we were able to install the scanner about 10 feet high. It would scan. It would basically inspect us at the floors. It would basically then give you a deviation straight away, and also find out the slopes of the floors that they needed to the drains. And all that was done in 1 minute. It was amazing. They saved a lot of money, and they would have never detected this if they hadn't actually done this. They would have never detected it with their eyes. It didn't actually run the scans going. Yeah, it was amazing. So I spoke to them just recently, and they said they can't believe how much money and time they've saved now.
Mm-hmm. I think another aspect to this that's important too is just in what you're saying now. We refer to as the CYA factor. So for 1 minute, again, a customer that I'd worked with previously had gone in, they were doing tiling in a really high-end residential. And when they put the tiles down, the floor wasn't flat. Of course, some of the tiles broke. And then you get that question, well, was it my fault? Am I responsible? Did I break the tile, or did I break the tiles because the floor wasn't flat? So then you get that disruption and you get that delay. Whereas in fact, as you said, for a minute, if I'm the guy that's laying that concrete floor down, I want to do that concrete floor. I want to scan it and I want to hand over proof that this floor is flat. So if you do break the tiles, you understand sort of who's at fault. So that 1 minute, as you said, to capture that scan, a couple of minutes, it just makes everything go smoother. And again, it's that risk mitigation, not just for the project, but for you as a contractor as well.
That's pretty cool. Anyway, moving on. Noah is going to show us some results that he's basically been like to showcase. So generating results to standards.
Yeah, so we've talked a lot about what BuildIT is, but I think it's valuable to see what BuildIT gives you. So what the output from the software is. And a lot of times I'm working with concrete contractors, like I think Irene mentioned that. That's a very common use case that's popping up these days. We're seeing it more and more. First, here we have a visualization of the ASTM E1155 standard in a report. So we have our FFFL values walked across the site. You can see the chart showing us our confidence level, showing us our actual values, showing us the pass-fail status. Then you have the really awesome graph here showing you the deviation or the flatness over the different measurement locations. Really, really handy there. Now, all the reports that you're seeing here, they're the basic output that is just automatically built into BuildIT. But there's other ways that you can customize this report, add your own views, add maybe a heat map to this report that isn't part of the standard necessarily, add a deviation grid. There's a lot of customization that you can do for this report before you hand it over to your client. So we give you a lot of freedom to adjust this and vary it depending on your need. So similar to what we were just talking about, we also have the ability to do surface deviation. So what you were looking at there, the concrete, it functionally is surface deviation. Here we have a heat map showing a project that I did with a coworker of mine at a bridge near her house. So this is a concrete slab, on the bridge over to the one side of it. We just scanned that, did a quick deviation on it, and actually this entire bridge, we modeled it in CAD as well. Kind of incorrectly modeled it on purpose so that we would have some deviations to show you on the next slide. But we also, something really cool I want to show you too here on the next image is verticality analysis. So here we can see wall plumbness and a deviation of a wall. A lot of times I'm talking to people who are doing elevator shafts. So it's really important to be able to see how that elevator shaft is, been built and if it's actually going to be able to meet the spec that they're trying to meet. We don't want to, have a wall that's, too far in, too far out. It's pretty important to keep those consistent, right? And this is a pretty cool building, this project. It's a really nice old brick facade, so you can kind of see certain areas where it started to sag a little bit. Yeah, it's a pretty cool project actually. But yeah, you can create that deviation analysis, export the report. You have your histogram there showing exactly what those different colors mean. And then you have the surface deviation analysis chart showing you the distribution of points across that surface.
That's amazing, Noah. That's really cool.
Yeah.
But have you done a lot of work on also comparing it to CAD? You were talking about comparing it to CAD as well.
Yep. Yeah. And actually, that's the next slide that we have to talk about is column and beam comparisons. So going back to that bridge, this is a quick screenshot of one of the beams that we modeled here. So we used as-built's automatic steel extraction to grab some of the steel, then after the fact, move it up a little bit from where it should be. And that gives us the ability to show this deviation. So out in the field, you scan the environment. You can see the scans there, bring it into scene, process, register, export out to BuildIT. And then you bring in the Revit model, which BuildIT does support import directly from Revit. It also supports IFCs and pretty much almost every standard CAD format. It's a pretty agnostic software there. We aligned that to the same coordinate system as our point cloud, and then we were able to do some auto associations between the surface of the CAD model and the point cloud, and then search and try to identify any deviations. Now on the right here, this is an actual project that I was working on out on a high-end residential where there were some problems that were occurring with the steel, and the client wasn't really sure what was going wrong. So we, went out, scanned it, brought that into BuildIT. We didn't have any known coordinate system, so this was just a best fit alignment, but that is something that BuildIT allows you to do. If you don't have known coordinate systems control, you can use tools within BuildIT to get it aligned to your model. It's a really powerful tool. But after we got that aligned, when we went through, we found there was some pretty consistent misplacements with those steel columns. I mean, here you can see just visually that column is not only out of place by about 1.5 inches, it's also twisted, right? It's not where it needs to be. And this is the kind of thing that you're going to want to find earlier rather than later, because this
Definitely.
is just the basic steel structure. Now imagine everything that's going to be tied to the structure, right? As things start to get tied to it, it's going to get worse and worse, and more money on change orders, more money on fixing this. Catch this early, and you're going to be paying a lot less money to fix it, right?
I think you've got a couple more pictures coming up.
Yep. Yeah, so this is a beam camber tool. So BuildIT does also give us beam camber. Like Irene said, ultimately every workflow in BuildIT boils down to more or less the same thing. You have a known and you have a theoretical, right? So the known would be your measurement with the scan, something you took out in the field. And then you have your theoretical, which is the CAD model, that nominal surface that you want to compare to. And that's what we have here. So we're seeing the point cloud compared to the CAD model, and we can see that there's some sag on that beam. What we're seeing here is the needle scale. So it's essentially an exaggeration of the deviation. I believe this was a factor of 20. So each deviation is exaggerated by a factor of 20 to show that, sloping camber across the surface of that beam. Here we also have, we're looking at surface deviations earlier of just flat surfaces, pretty simple, right? But here we can see we ran that same surface deviation on all of the surfaces at once of this beam network underneath the bridge. So you can see the histogram there really showing a really nice color gradient of all the different deviations there. So we can see certain areas it's a little bit higher, some areas it's a little bit lower. We can see specifically those cross beams seem to be a little bit out of tolerance there, but considering that we built this intentionally to be out of tolerance, that's to be expected. But yeah, it's just a really great tool. There's a lot of reporting options, and you can very easily identify when things are going wrong in the field before you have to, put on the next stage of construction. So it's a lot easier to fix now than later. And also, if you're going in to do a renovation, this is really important information to know. I was working with someone recently who they're actually modeling in as-built off the point cloud to, see how things are going to, or to add new features to the building, but they also are using BuildIT to check ahead of time against that CAD model to make sure that nothing's clashing, nothing's going to be causing any problems. So it's a really powerful tool for that kind of analysis.
And one of the things that I like to also point out is that you can actually automate everything as well. So you can actually write little scripts behind it. So if you are tending to scan and evaluate your items continuously, you can write little scripts in there that will actually scan, extract your information, and do the calculations, write your reports, all done in one easily. It's also in Python, right?
Yep. Yeah, we offer a pretty good library for that as well. Pretty good documentation.
All right, and I think Irene, I think you had a couple of projects with cut and fill that you'd like to share with us.
I think the cut and fill is something that, again, it's the estimating, right? And the example that you're seeing here, it's looking at patching. So this was in a parking garage. How much concrete do we need to fill the patch that they're working on here? And just by fitting a plane to the surface, we can do the volume calculation above or below the plane. And one of the most interesting ones that I had, it was a sinkhole. So there was a very large sinkhole that had opened up, and there was they were trying to figure out what's the volume to fill this. So even on a large scale, what you're seeing there is very small. It works to doing stockpile as well. And how it works is that basically you're seeing the scan, which you see in the first document there, and then we take that scan and we convert that to mesh surface, and then we use the mesh surface to calculate. So that's going to tell me the volume of what sits below your fitted plane. And again, in this case, we just fit a plane to the surface. If you have a known top of concrete, you can fit the plane to a known elevation, and then it will calculate. So, for example, with the sinkhole, right? We were able to calculate how much dirt there was above that we could use to fill, and how much volume we needed to fill. So in that one calculation, we could tell what was above ground, what was below ground, calculate the difference in order to fill it. Alternately, when you're working with this too, being able to take that mesh calculation again, and it will display giving you the above, the below, and surface area. So you're getting the pretty much everything you need to know on that. But it's in terms of doing. Trying to think of some of the interesting projects that we've had with backfilling excavations. Can we figure out how much we need? Do we need to backfill some of the excavation once foundation's been put in place? So, and again, it's that from when you're working with concrete in the field, the concrete truck shows up, right? And if you've got more than you need, then you're paying for it anyway. So to have that ability to sort of get that estimate a lot more accurate, just really get it down so that you're not showing up, having somebody show up at site with too much material or not enough, right? Again, it's that time and it's that push-on effect for your schedule. So being able to just do a simple either fit a plane or place a plane at elevation and then run that calculation to give me what's above. So if you are doing stockpile calculation or fill, if you're filling that sinkhole, pretty straightforward to do within BuildIT.
That's amazing. I was going to say, I think I know a couple of contractors that use this specifically for estimating, because you go out there, how do you estimate how much concrete you need? So he can actually estimate it. He knows what he needs, and he can give you a really good estimate before actually quoting the job, which is amazing. Yeah. I think you will. Yeah, that's right. You're going to talk about our tank analysis as well.
So tank analysis it's an interesting one. So basically, what we can do, the process for this is we take the tank. Now we've got some areas on the tank. You can see on that graphic there where there's some points missing there. But what we essentially do is we will fit a plane or a cylinder to the tank, and then we can restrict that plane to the normal, so it's sitting perfectly vertical in the z-axis. And then what we can do is we can run sections through. So there's input that you can, in this case, I think I ran them through the welds. I ran these cross sections through the welds on the tank. And then we can fit a number of vertical sections as well. And then what we can do with that is we can take that point cloud and then we can analyze those vertical rings that have put around through all the seams. And also we can take the vertical planes and then we run them through. So what you're looking at here is we're looking at the bulges. You can see that top tank's bulging pretty well. So we can kind of clock. We have a clocking point, so we know which one of these vertical sections we're looking at, and we can see where that tank is bulging. So we're seeing the histogram, so telling us the extent that it's bulging out along that vertical cut plane. And we can also do that out around as well. So what you're looking at here is the top view, and again, it's through the stations, right? So I've maybe got 4 or 5 different horizontal stations, so I can look through that and see where the outer round is on that one. The vertical is going to give me out plumb. This one's going to give me outer round, and it uses the needles, the same technique that Noah was talking about with the beams. So we can take that and we can really exaggerate it so that you can very clearly see the outer plumb and outer round using that exaggeration. In addition to that, we take the heat map and we lay it flat. So on the top image, you're seeing the unwrapped cylinder. So this is the flattened version of what that actually looks like. So you can see quite clearly so where the dents and the bulges are. And then if you're looking at the bottom there, we can actually give you some measurements on that. So not just a histogram, but some actual measurements. And it's going to be laid out along that grid that's created when we do the horizontal and the vertical sections. There's a lot of information on this. And the last one we can also do is we can actually do volume analysis on this one. So we take the scan and then we kind of calculate similar to what we did with the cut fill. So we make a mesh of the volume of the tank, and then we can run intersections and using based on create a strapping chart for this. So your strapping tables, you can see based on the height, the projected height of this tank, if that's where your liquid, for example, if that's where your fill level is, if it's half full, this is the volume. So to be able to create these types of insights into the tank is very straightforward with BuildIT. So the reporting, what we do find, a lot of people have they have their own, a lot of companies create their own tank analysis reports. They have customized ones that they use. So what BuildIT does is it gives you the tables, or it gives you the reports, and then you can take those reports. A lot of customers will take those images, take the information that's generated, and then use those to populate their own custom reports. If the ones that aren't here, that I'm showed, are very simple, but again, a lot of customers will take that and use it into a lot more comprehensive documentation. So it's again just simple scans. Just being able to extract all that information out of a point cloud is pretty remarkable.
That's honestly amazing. I know a couple of tank analysis that's been done, but some of our customers, and they love it because it's so much quicker than being on site to be able to scan it and basically generate out of round, out of plumb, because you can't really see this, right? So so this works extremely well.
Absolutely.
Well, that's the end of our webinar today. I'd like to thank you for attending. Just to summarize, BuildIT Constructions can basically help you monitor your projects in real time. You can compare your scans to designs. You can also make sure that it's compliant. So we have a couple of standards that you can compare to specifically for concrete floors, as Noah was basically explaining. This will also help you reduce your time, reduce waste, and your projects are going to be higher quality. Have you guys got anything else to add to this? Nope.
Not at all. Give Melinda a
call
do you have any
if you
questions? Want to try it out. We do have trials for this. Let me just point out that if you want to try it, we do have a pretty comprehensive section of tutorials and downloadable data on our knowledge base at Faro. And I think Melinda, you might have some on the DiCarlo website as well. So if you do want to try it out, you can request a trial and then use some of the online information, download the data sets, follow the tutorials. So if you do want to give it a try, it's available.
Yeah, so let us know if you need any help on this at all or any more questions on this. But this is just a quick summary on what BuildIT Construction can do to help you. And thank you so much, Irene and Noah, for attending this webinar today. Really appreciate your time and effort.
Thanks, Melinda.
Thanks.